Hello friends, Mr. Burrell here. We're starting off fresh, very beginning of the school year, talking about polynomials. You notice right here it says Unit 3. The order in which we're doing some of these units is a little bit out of order, but that's fine. I decided to start with Unit 3 entitled Polynomial Functions. This idea of polynomial functions is going to take up 2 full units, Unit 3 and Unit 4. So this is just part 1. We're going to start... we wanted to split it over 2 units because there's kind of a lot to cover. But before we get into what we're going to be talking about in this unit, let's review what a polynomial is and what functions are. So first of all, polynomial functions are used all over the place in the real world. You'll notice in a lot of the different career options that you might be looking into, some version of polynomial functions and utilizing polynomial functions are going to be used. Lots of application in engineering, lots of different application in engineering, tons. Lots of science application, archaeologists, astronomers, meteorologists, chemists, physicists, all use polynomial functions to talk about gravity, force, acceleration. They use it in finding new planets, calculating the distances between celestial bodies, projectile motion, like if I was to launch a rocket or something. All of those deal with polynomial functions. They use these types of functions in economics. In construction, you'll see me use the example of roller coaster designs fairly often. In the construction of bridges, lots of application in business, in markets, price of goods affecting sales, loan calculations, and the list goes on and on and on. You'll be able to utilize polynomial functions in some form in a lot of different areas in the real world. So I want to throw that out there here at the very beginning so all that we learn about know that this is what it's going to be applying to. Analyzing and looking at polynomial functions will help you in all of these different types of pursuits. Even if you're not going into any of these, there's probably still another concept or another pursuit that you'll eventually find where these will become applicable more than what we're just doing in class. So look forward to that. So I mentioned that this unit is called polynomial functions. So you've been introduced to what a function is in the past, like a long time ago. But let's review, what even is a function? When I say a polynomial function, what does that mean? Well, to put it simply, a function, let me go forward again, sorry. A function represents a system where I put some value in and I get some value out as a result. So you can think of it like a machine. I put the number 3 into this machine, I follow a certain set of rules, and I go through a certain process, and what I get out is 9. In this case, the function was x squared. So if I put in a 3 to this little function, this little machine, that would mean that this function turns into 3 squared. 3 squared gives me an output of 9. If I were to take that value of 9 and put it into a different function, say the function x plus 1, then I would put 9 in right here for x. 9 plus 1 is equal to 10. So a function really is just I put something in to a system or a polynomial or something like that, and I get some value out as a result. So you can think of that like when we're converting between Fahrenheit and Celsius, when you're calculating a distance traveled based on time. Maybe you want to figure out how far you're traveling from here to Timbuktu, and we can calculate that distance based on how fast you're going and how much time it took you to get there. That's what a function is. Before talking about all the math, it's just when I put something in, some number in, and I get something out in return. So a lot of the times you've heard in math that referred to as plugging a value in for x and getting out a value for y, because a lot of the functions that we look at are y equals something with a bunch of x's. And we're going to be talking about those something with a bunch of x's here in just a bit when we start talking about polynomials. So another kind of quick review, we talked about what a function is, and a lot in this unit and throughout this whole trimester really we're going to be looking at graphs. But what is a graph? Put simply, a graph is just a way to visualize how a function changes as you put in different numbers or different values. So like on this previous slide, you notice, let's go back here just a second. On this previous slide, I had this function x squared, and I had an input of 3 and an output of 9. That's super handy. Look, when I put 3 into this function, I get 9 out. But if I want to put in a billion different inputs, I want to see what all the outputs are going to be for a bunch of different inputs, it's going to be a lot harder to do that by just listing out all the number inputs and then listing up all the number outputs. So instead, we can represent that information graphically. So like here on this axis, I have my x values, or all my input values, and then each of those input values is going to match with the corresponding output value. So this input value matches with this output value. This input value right here matches with this output value. So a graph is just a way where I can say, look, here are all my possible input values from negative 200 up to positive a billion, whatever input value you want. This graph shows you what the output values are going to look like. That's what a graph is. So as we look at these different functions, as we look at these different graphs, keep in mind that that is how they are related. Okay, now I just want to show you a couple kind of real-world examples of where a polynomial function would come in handy in order to solve a problem. Because that's what we're all about in math. We're solving problems, right? So many problems. Thinking critically, solving problems. So here's an example. We're not going to solve this right now. I just want to give you a taste. But it says a shipping container in the shape of a rectangular solid must have a volume of 84 cubic meters. The client tells the manufacturer that because of the contents, the length of the container must be 1 meter longer than the width, and the height must be 1 meter greater than twice the width. What should the dimensions of the container be? So this is the kind of problem that someone could actually encounter in like an engineering perspective or in a construction perspective. These are the specific criteria that my container or my building needs to fit, and we can create a polynomial equation to be able to solve for, okay, what do the dimensions of this figure need to be? Again, we'll come back to a problem like that later on in this unit when we've kind of gotten all the information that we need, that we can solve that kind of a problem. Another example, this one says a new bakery offers decorated sheet cakes. I mean, if no one else can relate to this, I can. For children's birthday parties and other special occasions, the bakery wants the volume of a small cake to be 351 cubic inches. So here's like an inch. A cubic inch would be like that big, right? So the cake needs to be 351 cubic inches. That's a lot of cake. The cake is in the shape of a rectangular solid. They want the length of the cake to be 4 inches longer than the width of the cake, and the height of the cake to be 1/3 of the width. There are some really specific people out there when it comes to making cakes. Like for a wedding or something, or for a birthday party. This one specifically for a birthday party. So the question would be, what should the dimensions of the cake pan be? So again, this is an example of a problem that you could solve using polynomial functions. So we've talked about functions. We reviewed what those are a little bit. We've talked about graphs. We've reviewed what those are a little bit. Now, let's talk about polynomials. Before we do anything about and with polynomials, let's review what they are. Take a second to try to remind yourself this isn't something new. We've already talked about polynomials. In Math 2, you learned about polynomials. So now we're just going to go over really briefly what a polynomial is. So, in this first lesson, here are your objectives. This is what I want you to be able to understand by the end of this lesson. I want you to be able to know what the order of operations is and use it to solve expressions with real numbers. Again, the order of operations we're just going to go over real quickly reviewing because we have covered that before. And I also want you to be able to identify each of the definitions on these upcoming slides. We're going to go over several polynomial definitions that I want you to be able to understand. So, order of operations. So here's two scenarios I want you to look at. It says two people solve the following problem in the two different ways shown. Which do you think is correct and why? So, here's the first problem. 8 minus 2 plus 1. And then the second problem is 6 minus 3 divided by 3. So go ahead and, if you want to pause this for a second, take a second, look at the person A calculations and the person B calculations and try to determine who is correct. So, I'm going to tell you right now that this one right here for person A is correct. Number 1 is correct for person A. Person B is incorrect. For number 2, however, person A is incorrect and person B is correct. So if we remember the order of operations, lots of you probably think of PEMDAS, or please excuse my dear Aunt Sally, however you've remembered that, as the order in which we're supposed to perform certain operations in a string of numbers like this, right? So here, when I have 8 minus 2 plus 1, there's just a bunch of addition and subtraction going on, so it doesn't matter in which order we add and subtract, but we have to do it from left to right. So you notice here, person A took 8 minus 2 and got 6, and then added 1 to get 7. Person B, however, added 2 and 1 first, which they can't do because you have to move from left to right. So order of operations says when I'm doing addition and subtraction, I have to move from left to right. So that's why person A was correct here and person B was incorrect. With problem number 2, I have 6 minus 3 divided by 3. In our PEMDAS here, we note that before I do addition and subtraction, I have to do multiplication and division. So moving from left to right, I do all my multiplication and division. And then when I've done all that, then I move from left to right doing all my addition and subtraction. Okay? So note here that person B here was moving left to right. Notice that there was some subtraction, but he ignored that for now because we have to take care of the multiplication and division first. So he first took 3 divided by 3, which was 1. And then once he finished his multiplication and division, all there was left was subtraction, so he could take 6 minus 1 and give you 5. Whereas person A took 6 minus 3, did 6 minus 3 first and got 3, and then did the division to get 3 divided by 3 equals 1, which is not correct. So we have the order of operations because if I gave you these 2 different problems, note that it would be really easy to get different answers unless there was a pattern that we always followed, that everybody doing math everywhere knew how to follow. So in order to remain universal across the board, this is what we do. This is the order of operations. We have parentheses, exponents, multiplication and division, addition and subtraction. That is the order of operations, and that's going to come in handy when we talk about combining and working with these different polynomial functions. So, now we're going to get into these polynomial definitions. So I have a polynomial written at the top here. We're going to use this polynomial to give some examples of each of the definitions that we're going to go through here. So it says, write an example for each vocabulary word based off of this polynomial. So the first definition there on your guided notes and here on the slides is a variable. A variable is a symbol for a number that is unknown. In this polynomial here, that variable is x. X just represents a number that I don't know yet, right? We use variables to represent values that are unknown. So in this case, x. Constant. A constant is a monomial that doesn't include any variables, strictly numeric. In layman terms, it's a number without any variables. So right here is our only number without any variables. So our constant is 6. That number is not ever going to change because it's not being multiplied by a variable. Nothing's going to happen to it. It is constant. A term. A term is a single number or variable, or numbers and variables multiplied together, separated by addition or subtraction. So 6 is a term, x is a term, 4x squared is a term, 3x cubed is a term. They're just all individual numbers and variables combined, separated by addition or subtraction signs. So 3x cubed could be a term, 4x squared could be a term, x, 6. Those are all individual terms. Okay. Next, a polynomial. So here's the big one. A polynomial is an expression with constants and or variables that are combined using addition, subtraction, multiplication, and whole number exponents. So this whole thing is a polynomial because it has some constants, it has some variables, it has some constants and variables multiplied together. So this whole thing here, just this string of numbers and variables combined with addition or subtraction signs, that's a polynomial. Poly meaning multiple, so multiple terms added or subtracted together, that's a polynomial. And we'll notice later when we're talking about polynomial functions, we'll start to talk about the relationship between the input values that we would put in for each of these variables and what we would therefore get out, because that's a function, right? A monomial, like a like a monocle, it's just one. A monomial is a polynomial with one term. So if I just had, say, 4x squared by itself, that would be a monomial. Just one term. A binomial, like bicycle or bifocals, that means two bifocals, bicycle, two wheels. That means it's a polynomial with two terms. Two monomials combined together with addition or subtraction, a polynomial with two terms. So let's say 3x cubed minus 4x squared, that's a binomial. Two terms. A trinomial, can you guess? Like tricycle or trifecta, that's a polynomial with three terms. So say 3x cubed minus 4x squared minus x. That would be a trinomial because it has 1, 2, 3 terms being added or subtracted together. So polynomial, monomial, binomial, trinomial, they're all polynomials, just with a specific number of terms. Okay. Can we see this beyond my face here? Standard form is when the monomials within a polynomial are organized by degree in descending order. So degree, let's skip down really quickly to the degree here. The degree of a monomial is the sum of all the exponents on the variables within that term. So notice here's a term, here's the variable, here's the exponent. That exponent is the degree of that monomial. So the degree of this monomial is 3. The degree of this monomial is 2. The degree of this monomial, the exponent on this x is just 1, so the degree here is 1. And there is no variable here, so no exponent means a degree of 0. So standard form basically means that we order our polynomial from largest degree, in this case 3, to smallest degree, in this case 0. So I'd write that 3x cubed minus 4x squared minus x plus 6. And then again, the degree of a monomial, in this case, if I was looking at the monomial 3x cubed, the degree would be equal to 3, because that's the value of this exponent here. The degree of a polynomial is the degree of the highest degree monomial within that polynomial, blah, blah, blah. Basically, the largest exponent in the entire polynomial. So this one right here is the largest, so the degree of this whole polynomial is going to be 3, because it's the biggest exponent. A coefficient is the numerical part of a monomial. So the coefficient, if I were to take off this variable, I'd only have a 3 left, so the coefficient is going to be 3. If I look at this term right here, 4x squared, and I take away the variable, the only thing left would be 4. So the coefficient is just the number in front of a variable. The leading coefficient is the leading coefficient, leader, the first coefficient in your polynomial when it's in standard form. So in this case, the leading coefficient is 3, because it's the first coefficient. See that? It's the first number I even see in this polynomial, so it's the leading one, the leading coefficient. And last but certainly not least, like terms are 2 or more terms of a polynomial that have the exact same variables raised to the exact same exponents in the exact same combinations. So, say, I'm going to make up my own here, say I had 2x squared plus 7x squared. Those terms are like terms because they have the exact same variables raised to the exact same exponents in the exact same combinations. So I have 2x squareds plus 7x squareds, and I can combine those together. 2x squareds plus 7x squareds is 9x squareds. So when I have like terms in a polynomial, in order to simplify, I can add or subtract them together to take 2 monomials and combine them into 1. So those are all the terms associated with polynomials that we're going to discuss. We don't have a specific assignment on order of operations or polynomial definitions. We're going to get into our homework assignment with the upcoming lesson when we start to utilize and apply polynomials. But hopefully at the end of this lesson you now know that know a little bit more about the order of operations if you'd forgotten before, and are able to identify each of those definitions. That's a lot of definitions. Don't worry about memorizing all those, but keep those in your back pocket so you can refer back to those and be able to familiarize yourself with these different parts of polynomials. So I hope that was helpful, and I hope that you enjoyed that as much as I did.